I'm going to start off our discussion of computer science with objects and data types because they are so fundamental. A data type is a scheme for using bits to represent values. Values encompass all of the data that a computer can process, and data is described as being in one of 8 distinct categories, or more if you decide to create your own data types or use data types that have been created by others. There are 8 primitive data types: the byte, the short, the int, the long, the float, double, char, and Boolean. And each one of these represents a different kind of data. A Boolean contains a true or a false. It defaults to false. Its size is 1 bit because you are only representing 2 values. So you could imagine a scheme where 0 would be equivalent to true and 1 would be equivalent to false, or on or off, or etc. So this is what the bits are describing. How many zeros and ones do you need to schematically or logically represent this kind of data? A char is a Unicode character that requires 16 bits to be described. A byte is a signed integer. That means that it also contains a bit with a sign that denotes whether it is positive or negative. Default is 0. It has 8 bits. The char has 16. And each one of these numbers, so there's 6 of the data types, describe numbers. They all have a range of values that can be represented. The long, the float, the double can represent some of the higher values, while int, short, and byte represent smaller ranges. And you really want to use these if you're trying to use primitive data types that have a smaller size. But again, your range here is pretty limited. The difference between a floating point number and an integer is actually pretty similar as to what it is in math. A 5 with an integer is just a 5, but a 5 in floating point denotes a 5.0. So the floats and doubles can represent actual decimal points. So you would have to say double x equals to 5.2 to actually represent the value 5.2. Int of x equal to 5.2 actually sets x equal to 5 and ignores the point 2. Both of these statements are variable declarations. This is an overview of the different primitive data types which exist. There are also identifiers, and identifiers are very similar to the name of your variable or component or otherwise. So components here, you can really think of this as relating to variables. So it has to start with a letter, a money symbol, or an underscore. So this is what an underscore is represented as schematically on the computer. After the first character, you can have any combinations of character. So you can start it with an underscore and then place a pound sign. But you couldn't start a variable name with a pound sign and then put an underscore. So this doesn't work. This does work. That gets a check. Identifiers are case sensitive. So you see this example, foo and foo are 2 different identifiers. And a Java keyword cannot be used as an identifier. And a keyword here just means it's a class or it's a built-in method that actually calls another built-in function. So you can see here that this is a list of keywords which exist. So for example, public, you'll see that that's important because it's what starts a lot of your methods, a lot of your classes. Your main method starts with public. Public, static, void, main, and then you put in parentheses, string, args. This starts the main method. So obviously you can't use the word public as a variable name because it would think that you're trying to create a new method. Likewise with private, that's very similar. Classes, Booleans, all of the ones where you're really creating other classes or you're trying to perform built-in structural commands. I'm sure that switch is on here. That's a built-in sequencing control. True and false because it thinks that you're trying to relate it to one of the variables that has been declared as a Boolean, or you're trying to return a value that's true or false. While a lot of these that are involved with repetition probably aren't going to be allowed or aren't allowed as keywords, and keywords just means you can't name your variable. So cannot name your variable after one of these. Char, a lot of your primitive data types, byte, fall under this category. So there's always a reason behind why you couldn't actually, case goes with switch statement, there's always a reason why you can't use these variables, use these keywords to name your variables. It's because they have a different function or a different built-in function for the language, and they're recognized as doing those functions instead of being recognized as your variable name. So just try to avoid these. It leaves you with an infinite amount of options, so it doesn't really matter if you can't really use all of these. They're pretty unspecific anyway for whatever your context would be. And a variable is just a name for a location in memory. So the variable gets stored in a location in memory, and then you can use the variable name to get it out of memory. A variable has to be declared with the name before and the type of information that it'll hold. So remember, we talked about those primitive data types. This is where it comes back in. That's the kind of information it will hold. But you need to declare the variable first before you can actually use it, or before you can actually modify it in some way. So int total, just with the parentheses. That means I have a new variable, it's called total, and I can use it now in my context. I could say total equals 10. I have 10 ice cream bars or something, right? You can then use the variable in this context because it knows what primitive data type should be associated with total. It's an integer, so it knows what to expect beforehand. You can't just say total equals 10 because then doesn't recognize what total is supposed to be. It hasn't made a location in memory for it, and therefore it can't actually set it to anything. And another point here is that you can declare multiple variables in one declaration. This helps to minimize the amount of code that you're writing. Declaration statements. Here are some examples. You have an integer declaration. So remember that you can use an integer to actually write whole numbers like 10 or 100 or 999, whole numbers. You have doubles. You put a double in front of it. You see here you write out the whole word double, and instead of here you just write int instead of integer. You're going to have to memorize which of these words goes with each of the declaration statements. A double, you can store decimal numbers like 10.9 or 100.13 or 14 or 143, or as many as you want, until obviously there's a limit to the specific data type, but it goes on pretty far. Or you can store a variable like 3.141592, which is a good approximation of pi. A char lets you declare that this a char, you can then set it in single quotes to a single character. single Unicode character. So I could say it's equal to the letter K, but no more than that. The reason why chars are important is because Java doesn't have a built-in primitive data type for string. So all of the string operations in Java are just sequences of chars or sequences of characters. And it then operates on that sequence. And this is, again, another example where you're declaring multiple variables in one declaration statement. Likewise, after you have declared, so after you've made a declaration statement, you can have an assignment statement, and it changes the value of the variable. So for example, x equals 1, this sets x equal to the integer 1. This is the example with the char, and this is the example with the double. So you'll notice the difference again between the int and our double is that you have this floating point value, or a decimal to the right of the decimal point. Java also has support for declaring and initializing. So initializing is a synonym to assigning. You can do both of those in one step. For example, this is the example with our integer. This is the example with the double, with the floating point value. The float, which also supports a floating point value. These are the two primitive data types, remember, which support floating point values, or numbers to the right of the decimal point. And you can also use these to declare multiple integer types in one statement and initialize what those integer types are going to be. Constants are structures which are going to hold one value, or one char, or one character, or whatever it is, while the program is active. So this means that you cannot change. You cannot change the value. And it says here, while the program is executing. So obviously you can change it when you're working in your IDE, when you're typing furiously, but you cannot change it, have the program change it during the execution. And this uses the final operator. That's why you can't use it as a variable name, because it thinks you're trying to do this. Final, which signals that you're going to declare a constant. Declare a constant. Then you have the primitive data type that you're using. So in this case, it's a double. Then this is your variable name. And to the left of the equal sign, this is not actually an equal sign anymore. It's more of an assignment operator. I'm going to write that this is an assignment operator. And to the right of that, you have what you're trying to assign it as. So here we have 3.14159, 3.14159, and that is pi. The fact that one equal sign is an assignment operator becomes very important later when we're looking at comparison operators. Here's another example with the integer data type. Arithmetic expressions help us do math in Java. So an expression is a combination of one or more operands and their operators. Arithmetic expressions compute numeric results using the arithmetic operators. So we have, and I don't know why this came out weird, but we have addition, subtraction, multiplication, and division. Those are pretty straightforward. 2 plus 2 is 4. 2 minus 2 is 0. 2 times 2 is 4. 2 divided by 2 is 1. The last one is the remainder, also known as the modulo operator. And it finds, as it denotes here, it finds remainders. So for example, 3 modulo 2 equals 1, because 3 divided by 2 is 1.5. But 3 minus 2, how many times does 2 go into 3? Well, it goes in once. 3 minus 2 is 1. 3 divided by 2 is 1.5. But 3 minus 2 how many times does 2 go into 3? Well, it goes in once. 3 minus 2 how many times does 2 go into 3? Well, it goes in once. 3 minus 2 how many times does 2 go into 3? Well, it goes in once. So 1 times 2 is 2, 3 minus 2 is 1. That's how you calculate that remainder. But 4 modulo 2, that's 0, because 2 divides evenly into 4. If either or both operands associated with an arithmetic operator are floating point, the result is a floating point. So let's say I have a double here, and I'm saying double result equals 1 plus 1.0, right? What is result going to equal? Well, we have this integer type, 1, and we have this floating point value, 1.0. Well, it says here that this result is going to be 2.0. It's going to be a floating point value. The result isn't going to take the integer value. It's going to default to the floating point value. That's important to know, especially once you start doing operations where you're using variables which you had declared before as an int. So if you have int x and double y, the result of x plus y, or x times y, is going to be a double. It's not going to be an integer. And you have to make sure that you're aware of it and that it makes sense in whatever context you're putting these variables. If both operands to the division are integers, and note here that it says if both operands are integers, the result is an integer. So 14 divided by 3 is 4. 8 divided by 12, well, that's 0. And you're seeing here that I'm automatically rounding down. That's because there is in Java a round operator, math.round. We haven't gotten to it yet. But this doesn't automatically round it for you. It just says, okay, I have 2 integers. How many times does this integer go into that integer? It's not concerned with, well, which one is it closer to? No, that's not what we're doing here. We're just saying how many times does this integer go into this integer. The remainder, so the percent sign or the modulo operator, as you'll remember it, returns the remainder after dividing the second operand into the first. So here you have the remainder that was kind of lost when you were doing this operation. So these are some good examples. This is going to be equal to 8. These are good examples. This is what you've lost when you did this integer by integer division, more or less. And this is some good practice if you want to learn how to use, if you're unfamiliar with how to use the modulo operator. There's some great tutorials online for it. There's also operator precedence, which is very important to realize when you're sort of looking at it. Operators with the same precedence are evaluated left to right. So this is very similar to what we kind of did in math with the PEMDAS. Remember, that means parentheses, exponents, multiplication, division, little r, remainder for remainder, addition, and subtraction. So multiplication, you kind of always organized it like this. Addition and subtraction are the same level. Remainders, division, multiplication, those are all on the same level. Exponents, and then parentheses is at the top. And then it kind of starts all over again when you put stuff inside parentheses, inside parentheses, inside parentheses. But that's the basic idea of it. So if you look at this example here, you would first do this division, then you would add total to whatever this turns out to be, and then you would subtract offset from the, essentially, the total plus whatever this evaluates to. So you see here some examples of the order of evaluation. When you add them all together, it's pretty straightforward. We have a division and a multiplication, so the multiplication comes first, the division second, then addition, then subtraction. Well, first there's the parentheses. Second is the division, third is the remainder, and fourth is the subtraction. First is what's inside the parentheses, then what's inside the slightly larger parentheses, or the parenthesis of medium size, then the multiplication inside of the parenthesis. So this is how something to the right is put in front of something to the left in terms of precedent. And then you have the overall division. So now I'm going to talk a little bit about what the scanner is. The scanner is a module which is used to read multiple values from a line, or just read in data from the user interface, or the UI. It uses a scanner. You have to import the scanner because it's part of the Java utilities classes. Inside of, this is our main method right here. Inside of the larger class, so this is sort of our personal project class. This is what we're creating. Here's how you declare a scanner. You say scanner, so you're calling the scanner class from the Java utilities. This is the name of the scanner. The new operator tells it to import a object scanner. So this is like a mini import, you could say. And then you have scanner system.in. And this tells it that you want input from the console. Then this statement is just like for your instructions. And then you can call in ints. So this is, remember, the name of the scanner, so you know that you're calling the scanner console that you created earlier. This is actually a declaration statement, kind of like you've seen for the primitive data types, but this is for something more complicated, a more complicated module. And then you're calling these methods to import integers. And you don't just have to import integers. This could also say next double, next line. The line brings in a string, which we haven't really been sensitized to, but you can also import strings. That's just sequences of characters. So I like pie. That's a string. And strings are usually denoted by these double quotations. You see the instructions here, that's a string. You put it in double quotes, please type in 2 numbers, end quotes. This is an example of a string too. And then you can do the rest of your operations. And it's always important when you're writing these programs that you have something called a test case. Our test case here is 8 and 6, and the product would be 48. So we also want to learn how to do data conversions. So you want to convert data from one type to another. So for example, if I wanted to convert an int to a double because my method requires doubles, which is a very real possibility, especially when you're working with methods that are more obscure or methods that have been built by people outside of the advanced community. If you're using something that's been generated by the community, by the Java community, they might require specific types of data because they know that other types of data will make their method or their program malfunction in some way. So they may require a certain type of data. But you need to remember, always keep in mind what the context of your own program is so that you avoid losing information. And we'll see what is involved in that. So when you're widening the conversions, it's the safest because there isn't a lot of chance or no chance that you're really going to lose any information. So if I take an integer like 5 and I convert it to a double called 5.0, I haven't really lost any data. This is still representing the same value. It's just using a different data type. So the double actually contains more information, but again, it uses more memory, it uses more storage. If you narrow a conversion, you can lose information. For example, if I take a double 5.2 and I convert it to an int, that's a 5. I've lost one significant figure by converting it. If I convert, though, a number like 5.0 to an integer 5, then you'll notice that I haven't really lost information. But I did need to know that my number 5.0 was always going to be an integer mathematically in order to do this, in order to narrow the conversion and not lose any information. So the next point is how you can actually convert this data. That's the question, how? And there's 3 ways: assignment conversion, arithmetic promotion, and casting, which is my personal favorite. Assignment conversion is when a value of one type is assigned to a variable of another. But you can only really widen conversions via assignment. So for example, I say, okay, I have this integer, it's a, and then I wanted to widen the integer into a double so that it can perhaps store floating point values at some point in the future. So I say that double a, b equals my original integer a. So now b equals 12.0. There's this floating point value that I can change in the future as necessary. But again, assignment conversion is very limited because you can only widen. The second type is arithmetic promotion. And this is kind of context dependent. It happens when you apply an arithmetic operation with 2 variables that have different data types. So for example, if I have an integer and if I have a double. Or just to change it up a bit, if I have a short and I have a float, that would also work. Any 2 that are sort of in opposition, more or less, or 2 different ones where one is clearly favored over the other. Arithmetic promotion is done before the calculations. It widens it, more or less, to the largest possible stance. So if I have an integer and a double, it's going to pick the double because I have a floating point value to take. If it's looking between short and float, it'll take the float because, again, there's a floating point value there. And one thing that you should know is that double overrides all of the other data types. So for example, in here I have an integer a equal to 2, a double b, that's 4.5. The product, this is turned into a double, and my result is a double. So this again favors widening. Casting really provides the most flexibility. And I'm going to write that down. It's flexible. You can widen, you can narrow, whatever your method means. This is what you can use very easily in order to use methods that require a very specific type. To cast, you need to put the type in parentheses in front of the value that's being converted. Here's an example of it. The casting will be done first, before the actual calculations, or before it calls the method that you're inserting this new variable to that's being casted. Because casting means that you want to change it so that you can use it for something that you weren't able to before. So it does that first. Total and count are integers, but we want a double result. We can cast total. So total might have been 12 and count might have been 6, but by having this casting, it's 12.0 and the result is 2.0. But even after the casting, total and count are still integers because we didn't say total equals double total. This actually changes the characteristic of the original variable. So now this isn't an integer anymore, it's a double. We can also use an enumerated type, which is a different data type. So again, this is where these other contexts begin to come in. They use a small fixed set of data. For example, the seasons of the year, we know there's only 4 seasons. or the days of the week, there's only 7, or grades, which are, there's usually 5 different types of grades, but again, it just really depends on what your system is. But when you have a small fixed set, you can use an enum data type. These are declared outside of the main method, but still inside of the class that you're creating, and they're declared in the following fashion. Enum, to show that you're creating an enum, or a small fixed set data type. This is the name of your new data type, and then these are the pieces of information. So like a list of data objects that are inside of this small fixed set. And now you can declare variables of this data type. That's why I called it a new data type. We've been declaring variables the whole time, which have data types that mirror the primitive data types that we learned at the very beginning. Well, now you can take data or values from these small fixed sets and create a new data type that is just all revolved around them. This is a declaration statement, and then this is your assignment statement. So I'm assigning time to one of these values inside of the small fixed data set. So the enum types we just saw are examples of objects. So any data type that you invent, like the enum seasons that we made, those are going to be types of objects, or an object. Everything, all the 8 original data types that we used, for example, byte and short and char, etc., those are all primitive data types. And Java already has a lot of built-in data types, not just the 8 primitive data types, but also objects. For example, the string object is built into Java, even though it's not one of the 8 primitive data types. It's the string, or the list of chars. Objects represent something with which we can interact with the program, or which we can really interact with the program to create something for ourselves, something that we can program and then use. So objects are things which we can use, more or less. So we have an object and then methods which are associated with that object. So that's represented by these letters that I've made here. The object is something that we can interact with as a programmer to call upon these methods that are related to the object. The object often represents something real, or something that we want to simulate. And each object has a set of behaviors that is associated with that simulated reality, or associated with those methods that are really what define this object. And states, that is what the object naturally does by itself, without the programmer actually calling it. Or when the programmer does call it, if not everything in the method for the object is a parameter, what are the default settings for how the object interacts, or what the object is supposed to look like. So let's look at a big picture overview. If we have a class, for example, a bank account, we can put objects inside of that class, which are individuals' bank accounts. So there's multiple objects inside of this class, and then each of these classes can have methods associated, i.e. a method for who the owner is, so who owner, and then a method for the balance, so BAL. And each one of these objects has this method associated with it, etc. And you can do that for all of the objects. Obviously, a bank account has a lot of individual objects, so it's good that we can organize the whole structure in this hierarchical way. Here's another example. You have a class dog. These are the different types of data, or the different states that exist for the dogs. So these are like the states, and then these are the methods. So this is what determines how you can interact with the class dog. So this is like the class, which defines overall what we're really looking at, and then each one of these dogs is an object. So I have a dog that looks like this, I have a dog like this, and another one like this, and these are all individual dog objects which I can then interact with in the program however I like, or however I really define it. This is another example of a object using students, very similar to the last example. I'll move on. Again, this is a topic known as the idea that then you can take classes, like we had this bank account class, and merge them into larger ideas. So the total idea of an account, because there's a difference between a bank account and a charge account, or the difference between a savings account and a checking account inside of my bank account, that I can merge classes into classes. This is a topic that's called inheritance, and it really makes Java unique because you can organize very complicated systems into these hierarchical structures that can then be, you can interact with simply. And this is what was very revolutionary about Java in the first place, this object-oriented approach that allowed for inheritance. And again, class, as I just mentioned, one class can be used to derive another via an inheritance, and they can be organized into hierarchies. So here's another example where you say I have all of my vehicles, and then I organize them into smaller classes like two-wheelers, three-wheelers, four-wheelers. Objects are statements that we've kind of already used up to this point. The system.out object represents a destination to which we send the output. But this system.out part, this is an object in and of itself. We have the object called system, and we're then going one level deeper to the out object, and then we're looking at a method, println, that's inside of the out object, that's inside of the system object, which can then print hello world. What is our parameter provided to the method? It can then print hello world to console, or print hello world to the console. So this is something that we invoked on the very first day, and we were using these concepts even though we didn't know it. Java also has a lot of abstraction, which hides details which aren't really all that necessary for us to understand, so that we're able to really do what we want to do without a lot of hassle. For example, we don't really know how println actually does it, or what memory it's invoking in order to print it to the console. We just know that it does it for us. And that's very helpful, because we can write complex software without getting bogged down with all the details for every single minuscule operation. So generally, we can use the new operator to create an object of our own. And you saw that when we created the new scanner object. This is an example of a string constructor. Remember that strings were these sentences that are in double quotes. And the string constructor is a special method that sets up this string object. When you create an object, you are instantiating it. So remember, when we created a variable, it was called, we declared it, and then we initialized or assigned it. When I'm creating an object, so I'm going one level of abstraction higher, when I'm creating an object, it's called instantiation. And an object is an instance of a particular class, because remember we organized it where we had our class at the top, and then there were objects inside of the class. Because strings are so common, we don't actually need to use the new operator to create a string object. We can just say title equals, then in double quotes, Java Software Solution semicolon. So this is just like our primitive data types, and it's because strings are so common. So strings are like the exception. They're not actually a primitive data type, but we can still use them. We can still do the same thing just because they're so common and they're so widely used in other languages. Once we have an object that's been instantiated, we can use a dot operator to invoke its methods. So strings have a method called dot length and then in quotes. This just means it's calling the length method and it's not giving in any parameters. And this will provide the number of characters that are in the string. Here are some other methods related that are inside of the string class. Again, string's not a primitive data type, so it has all of these cool features, being a class. And it's useful, these methods are very useful for when you want to manipulate strings. Many of the methods return a value, such as the length method here, that's either an integer or a new string object. So the new string object comes after I manipulate the string to change it in some way. The integer probably is just information about the string. Like the string length here, well, that's just information about the string. This will give us a new string object because it changes the fundamental property of the string. It changes this all to lowercase. Same here. This one doesn't change it, but again, it gives us a string output because it asks us what is the char at this specific index. So that parameter right there, that's an index. And then there's many, many more methods inside of the string class that can be used. The Java AP sheet contains a list of which ones that you should be really familiar with by the time you sit down on test day. So I'd recommend going and checking that out. The math class is part of the Java Lang package. So similar to the scanner class, the scanner, as you'll remember, is part of java.util. So this is part of a different package, but it contains methods that perform various mathematical functions that are more complicated than our arithmetic operators that we looked at before. Remember, those are plus, minus, multiplication, division, and remainder. The mathematical functions that are in the math class include our absolute value function. It's usually represented by 2 bars, our square root, our exponentiation, like so, our trigonometric functions, so sine, cosine, tangent, and you can't forget cosecant, secant, cotangent. And you can also generate random numbers, although the functionality of what the math class can do in terms of generating random numbers is a little bit limited, which is kind of why we import a different random number class when we're trying to create random numbers of integers, let's say. So these are static methods, which means you can just call them directly from the main method. You don't need to create an object of the math class. And the math class is also so widely used and so popular that you do not need to import it. You do not need to import the math class. So right here you see an example of how this is used. You have a value, math.cosine of 90 plus math.square root of delta. So you can see there that you had to put math dot your operator, and then the parameter inside was the number. Here are some examples of math functions. We talked about the absolute value. Ceiling just returns the number that's highest. So 3, ceiling of 3 is 3, but ceiling of 3.1 is 4. So, and the ceiling of 3.01, that's 4. So it just brings it up. Exponents returns e to the x, where e is 2. So this is using base e. You can also use math.pow and this will allow you to specify what your base is and then what your term of exponent, what you're raising it to. Floor tells you, so if you have 3, that goes to 3, but again 3.1 goes to 3, and 3.99, that also goes to 3. The log function returns the natural logarithm. And you should see over here that the argument and the result for most of these are doubles. And that's a trend that continues throughout the math function. So here's some other examples. The max, the min, tau, which I just kind of described. This is the random function that's built into the math method. The random function is just a little bit limited because you can only generate a pseudo-random number between 0.0 and 1.0. So it just generates a long decimal, which sometimes is useful depending on the context, but other times it isn't. Rint, that's an interesting one. Round, square root, a lot of the ones that you're familiar with. But again, the random number piece is just a little bit limited. So we have a math.random, but we also have a random class, which is actually part of the java.util package. So this is the same as the scanner, and it provides methods that generate pseudo-random numbers, but specifically integers. That's what we're looking to do here. So you first need to generate an instance of this class. It's not like the math class. You do need to say, I'm going to call the random class, I'm going to instantiate a new random object, and then I have this variable name. And in this case, I'm just calling the random number generator rand. Then you can invoke methods like next int, next double, next long, next, and then basically any primitive data type number. And it will, if you're using rand int, it will generate a number between -2,147,483,648 to very similar number on the positive direction. And this is inclusive. So while it's very unlikely, you could generate these really long numbers. We can generate different types of numbers, including integers, floats, double, long, even Booleans, true, false. You can generate shorts. You can generate, I'm sure, bytes, all of the different types. So you can pass arguments or parameters into the methods for placing an upper bound on the range of numbers generated. So next int 6 will create a range from 0 to 5, both inclusive, so you could represent that as 0 to 5. And this is, it'll kind of give you one of these 6 numbers. Just note that whatever you put in here, the upper bound will be 1 lower. So as you'll notice, 6 minus 1 is 5. So if you wanted to generate random integers in the range from 0 to 999, it would be next int 1000. If you wanted this number to be 1000, this would need to be 1001. There's also a Java text package, which is something we haven't seen before, but it has static methods that let you format objects. And format objects means you can format strings here. Currency instance, percent instance, this changes it so that it turns a number into a percent. So it can be strings or numbers too, or I guess any object that really fits these parameters. In currency instance, this changes it so that it puts a $sign in front of it and rounds it off to 2 decimal points. Each formatter has a method called format that returns the information in the appropriate format. So it returns a string when you use the formatting instances with these text packages, which makes sense considering that you're adding in these special symbols when you're using these methods. And this is just a way of formatting output so that it looks nice for the user. So here are some examples of this. You're printing out a subtotal, so you're using so these two are essentially instantiating the objects, and right here you're just using them. So I'm saying FMT1, so that I can turn this into a currency. So I can put a $sign in front of it and round it off to 2 decimal places. And the same thing here when I'm looking at the tax and when I'm looking at the total. The total is with a $sign. The tax is as a percentage. So you're using the percent instance. You can also have a decimal format class inside of this text class, by the way. So we're doing another level of inheritance here. We have a text class, and then we have all these different formats. And this allows you to specify to a specific number of decimal places. So an X number of decimal places. So this example down here uses a decimal format that goes to 3 decimal places represented by these pound signs. But you could also have 4 pound signs, and that would represent 4 decimal places, and 5 would be 5, and 6 would be 6, etc. So here's an example of where that would be used. You want to round your area off to 3 decimal places. You can then call upon the decimal format. So Java has a lot of sequence structures built in. And if you'll remember from CSP, we had sequencing, we had selection, and we had repetition. So sequencing just refers to the order of your code, and Java just goes from top to bottom. It's dependent on how you actually originally wrote the code. Selection is when you use one of these 3 selection structures to differentiate or to compare between values and then make decisions based off of that. The 3 selection structures are if, or basically if else, and switch. So an example of if is like this. If your condition is true, so if 2 is equal to 2, then I want to print out true. So system.out.println, print new line, and then in parentheses, double quotes, true. That could be something. And if the condition is false, well then, nothing. If, then else, changes that. Because if the condition is true, it still print out true, but you could also have it print out false, for example. So if 2 equals 3, well it doesn't, that's false. So it doesn't print true, you could have it print false using the else statement. So these statements, this if or the if then, else. So it's always if then. But it could be if then, or it could also be if then, else, if, then, and then your else. So you can have nested if statements checking for multiple parameters. But if you're doing that, you should then really consider the switch statement, which we'll go over in a minute. But when you're comparing, oh, if this, well, what is this? Well, it's something that relates 2 values. And these are the operators that you can use to relate those 2 values. You can say, is it equal to this? And this is an equality sign. So remember when I said it was very important to differentiate the difference between this and this? Well, now is the time that it becomes important, because this is your assignment operator. Remember, 2 equal signs is the equality operator. Exclamation point equal sign is not equal to. Then our greater than symbol is very similar to the one that we use in mathematics. Less than is just the opposite of greater than. Greater than or equal to is the greater than symbol and then an equal sign, and less than or equal to is the less than or symbol and an equal sign. So here's an example of an if single selection statement. So if the grade is greater than or equal to 60, print out you passed. So this is a schematic diagram of what's going on here. It only performs the action when the condition is true. Single entry, single exit control structure. If then else performs one action if the condition is true, and it performs a different action if it's false. And you can also have nested if then else control structures. So this is an example. If the grade is greater than or equal to 60, you say passed, otherwise you say failed, but you only do one or the other when you're running this. And there's a schematic again. And this is an nested if then else control structures. So the way that this works is that, let's say num equals to random. If that's true, then say you are correct. But if this isn't true, then you go to the next one. Else if num less than random. If this is true, then you say too low. But what if it's not? Then you system, then you print out it's too high. So you check this value first, then you check this one, and then this one. But this is an example of a nested if else. If you're having too many else ifs and you have a predictable input, then you should consider the switch statement, as I mentioned before. Just be careful when you're doing nested if statements, because let's say you wanted to, in this case, just print out one thing instead of printing out both things. You see here, if number equals 0, you print this out. And then based on sequencing, you also print this out. This here needs to be in an else statement, just to make sure that you only print one thing or the other thing. So just make sure that your logic is correct as you read it from top to bottom, and that your output returns what you were expecting. And you should always try test cases that, again, are going to force all of your results. So you try one test case for one result, then you try another test case, that'll get a different result, but make sure that everything's working and that you try enough test cases to ensure that. So here's another example of a if-then-else statement, but here we see the difference is that there's a conditional operator, and this means and, this one, the two ampersamps. So the age needs to be less than 21, and the grade has to be greater than or equal to 10 for, I believe, the student. And this didn't print out very well, but and was the two ampersand symbols, and or is two vertical bars, or just vertibars, as they're also called. The two vertical bars down are the or symbol. So if I put an or symbol here, that would mean that the person could either be greater than or equal to grade 10. So they could be in any grade higher than 10 or under 21 to purchase the ticket. It didn't matter if they were in grade 9, right? As long as they were under 21, they could still purchase the ticket. That's the difference. When you have an and, both conditions need to be true. Gives you the true. If you have any false, then you get a false response, a false condition. The or means that one or more true. And if you have all of them false, only then do you get a false response. The switch statement, as I mentioned before, is when you have predictable cases. So this allows a variable to be tested for equality against a list of values. Each value is called a case, and the variable is being switched between all of these different cases. So this is an example. This is our switch statement expression at the top, and then whatever the variable is that is inputted here, that gets compared to these numbers. And if any one of these are true, only then does it run the code block and then exit out of the code. But it goes all the way until the end, and if none of these match, it goes to the exception handler case, which it then runs and exits the switch statement. So it's just a more condensed version of an if then else, if then else, if then else. This is a good example. Let's say we had a sign. So we entered a 1, 2, or a 3 sign, and we're modeling some rock, paper, scissors game. If we have a 1, then we get a rock, or a 2, or a 3. Otherwise, we get, so if a variable sign doesn't equal 1, 2, or 3, then it just moves to the default case. And the syntax is something that you just have to kind of get used to in this case, but I hope the logic is very clear. We have a variable that we're inputting into the switch statement, we're comparing it, and based on whichever case it matches, then that code associated with the case is run. And if nothing matches, we just go to the default case, run that code, and then exit the statement to move to the next one, which would be our final print statement. And this here is also code that's being run by each of the cases. And the break just refers to the fact that we're exiting the code, the whole switch statement code, after we've finished, after we've identified a case, just to make sure that it doesn't go down to the default case and still run it even if it was equal to 2, let's say, or it was equal to a case before. If you haven't noticed already, this is using the scanner class. It's not shown in the screenshot, but there must have been a scanner object that was defined beforehand. So this is the end of our slideshow. I hope that you found this helpful, and good luck.